This is a Triple J podcast.
Hello, Lucy Smith with you, back in your feed for Science with Dr. Karl. And before we get into this week's episode, I wanted to say a huge thank you to you if you came along to Science with Dr. Karl live on Monday night. It was one night only at the Enmore Theatre. There were so many of you there ready to soak up every ounce of knowledge from Dr. Karl. And that's what I wanted. I wanted this segment to be on the main stage and for you to see exactly how Dr. Karl's brain works. It was a Monday night. Everyone was so up for it, and you are going to get a slice of that action if you weren't there. Keep an eye on your podcast feed and on Triple J's YouTube channel. Make sure you're subscribed because we are going to be taking you there. You can watch it back. You can listen back to Science with Dr. Karl live at the Enmore Theatre for the very first time. And hey, maybe you'll learn something new. Anyway, let's get into this week's episode. It's National Science Week. Of course, we kicked it off with our live show. And this week, we had Krystal Napoli in, who is a science communicator specialising in astronomy, astrophysics, and First Nations science. We had so many questions about black holes and the ThreeI Atlas and whether that is an indicator of new life. And we also took some of our questions from Science with Dr. Karl Live. Krystal weighed in, and you'll hear it all in this week's episode. Let's do it. Dr. Karl, on Monday, for one night only, we kicked off National Science Week with a live show at the Enmore Theatre. How are you feeling?
It was amazing to work with such professional people from Triple J who fertilised the soil that all you and I had to do was concentrate on being there.
Yeah.
And my God, the audience was just so lovely. The bottom floor was full, the top floor was full. You could feel the love in the room. My wife was in the audience and she did. A few people were muttering like, "Aren't they great?" And they kept on muttering, "Aren't they great? Aren't they great?"
We were so excited, and all it was what we do every single Thursday, which is answer your science questions. We had people in the room submit their questions, and we just got to them one after the other. We had some special guest questions as well.
Beaming in the special guest by video on the screen. Now, that was nice.
That was really
That was a whole
special.
extra dimension.
We had a couple of people which you're going to hear from later in this episode, but also, Dr. Karl, I wanted to tap into something that I care about, which is music during the show. And I put some science of lyrics to the test. You know, I wanted to see how some of our favourite songs stood up scientifically, including Addison Rae. Addison Rae, Diet Pepsi. Oh, wait.
Break all the rules till we get caught. Fog up the windows in the parking lot. Summer love, sexy.
Okay.
Fogging
Fog
up the windows
in the parking lot. How long would Addison and her man need to be in the car to fog up the windows?
Okay, I need more information. Is the car stopped or are they doing everything while they're doing blockings?
Honey, it's stopped. They're
Okay.
breaking all the rules in the parking lot.
Okay, so in that case, it depends on how cold the air is on the outside and how active are they?
Her cheeks are red.
Oh, her cheeks are red,
like
okay.
cherries.
Right, okay, so she's radiating heat.
Yes,
I'm
from
getting,
her face,
I'm
of
guessing
course.
a couple of minutes.
We'll
Can
be,
somebody do the experiment? And if you... but you've got to document it. Remember, the difference between science and screwing around is you've got to write it down. So write it down and you could win a Triple J fun pack.
So we need people to test that foggy windows theory. But Dr. Karl, it was just so much fun. And we can relive it. It's going to be up via Triple J's YouTube channel in two halves, the first half and the second half of Science with Dr. Karl live at the Enmore Theatre, plus in the podcast feed as well, so people can listen back to it and we can relive it again and again, Karl.
Oh, it was so much fun.
So good. Hey, it is National Science Week, and today we say a big happy National Science Week to Krystal Napoli, who joins us. Krystal, welcome back to the show.
Thanks, Lucy. So lovely to be here.
Now, Krystal, you are an astrophysicist. You are someone who can look to the skies, but also you have a hell of a lot of First Nations knowledge as well as a Gomeroi woman. Can you tell me what is one of the discoveries recently or something you've learnt that's blown your mind a little bit?
About the universe, or?
Yeah, I reckon about the universe. Let's go large.
Yeah, well, I mean, I guess I'm really interested in a lot of the developments around the Hubble tension. So for those who aren't aware, essentially we are trying to understand how big our universe is, how fast it's expanding, and we do this through all of our different observations. And what is so fascinating to me is the fact that there is this massive question mark over essentially a calculation, a very important number, that helps us determine the speed of expansion of the universe. And so it's fascinating because if you go through via theoretical models, you know, the way we've seen things from the Big Bang and following the physics and the laws that should guide it, we find that we get a certain number of this value, this Hubble constant. And it's approximately like 67 kilometers per second per, megaparsec. You know, that's all great values for you to have. But there's also a different way of going about calculating. That's through direct observations. And there are certain stars we know the properties of super, super well. And when we look at those stars, all of a sudden things aren't adding up. And the values that we get, while it's very similar, it's a double-digit number, it's so close on the scale of the numbers we deal with in the universe. It's approximately like 70, 72, 74, it depends on the studies. So that is super, super, super weird. And so I'm very fascinated, and it applies a little bit to the research that I'm beginning at the moment about what is it about our observations that might be leading to this tension in those numbers?
Ooh.
Yeah, because there's two different ways of looking at it. And the thing is that in the early days, they kind of overlapped. But as the measurements got better and better, they started splitting further and further apart. And on one hand, there might be something wrong with our numbers or something else, or the universe, our local bit of universe could be different, or we are very wrong about what we think about basic understanding of the universe, and this could lead to a Nobel Prize for somebody, and everybody wants it to be a Nobel Prize and a big breakthrough, but it probably won't be, but we want it to be something big.
It's one of those big questions. And so my research is a tiny, tiny little corner of this overall big question. But that is exactly what we're talking about, Dr. Karl. So looking at the local mass density and seeing if it's the presence of certain voids that have thrown off the model option. So trying to figure out why a model doesn't match our observations. Is it the observations that are being impacted by distance and lensing and crowding of stars? Or is it our original understandings of the universe's beginnings? So it's a big question.
And big question. And also the knowledge that you can question those models and you can look back at them as well. If you've got a question for Krystal today, feel free. Astrophysics, astronomy, First Nations science, 0439 757 555. You guys ready to kick it off?
Yeah.
Ready?
Let's do it. We're starting with Kate in Wagga Wagga. Dr. Kate, what do you want to know?
Hello, good morning. I just wanted to know, what is the likelihood that our known universe is actually existing inside of a black hole?
There was some research earlier this year where they started looking at galaxies rotating. And if you look at the universe in general, half should rotate this way, half should rotate that way. And what they were doing was looking at galaxies, a small subset of them, using the Just Wonderful Space Telescope. And they looked at extremely old and distant galaxies, not the average of all the galaxies in the universe. And they found that 60% of them rotated one way and 40% the other way. And this was weird because really it should be 50-50. On the other hand, it was a very small sample size, so the likelihood... And the way you can explain this is, if you want to really stretch it, is, all the galaxies in the universe, if you extrapolate from a couple of dozen or a couple of hundred up to all the galaxies, you say, obviously one possibility is that we are inside a rotating black hole. And that's what happened with the Daily Mail. The Daily Mail said that. And remember the old saying, is it true or did you read it in the Daily Mail? And so it is possible, but it's kind of about as possible as the Pacific Ocean freezing over tomorrow. But it's not impossible.
Yeah, it's definitely one of those interesting ideas that has a little bit of evidence to support it, which throws me off more so than I'm expecting. But at the same time, as you're saying, it is quite a science fiction sort of a leap that we could expect that to be our reality. I do like, though, some of the themes around the idea, because it's this idea that there is some essentially other larger universe with a parent black hole that instead, once you pass the event horizon, and for those who aren't familiar with black holes, and I mean, you probably are if you listen to the show regularly, but black holes essentially are objects that are infinitely dense to the point where not even light can escape its gravitational pull. And so we see, not really them, but we see essentially the absence of light that they create in this event horizon, the point of no return. And so this idea is that within a parent black hole, we have our observable known universe, which has essentially bounced into existence. So it's one of those more sort of like optimistic takes in a way of, well, is there a cosmic cycle to the universe coming to being? Because, I mean, that's another one of those big questions that we'll probably never get to answer. You know, why did the Big Bang sort of begin? What was before and what's going to come after? So it sort of tends into that idea of that sort of like that little cyclic closed universe that maybe each sort of Big Bang comes to an end in a sort of black holes type of situation and then bounces back into life. So a bit of sci-fi, but I really like the question and exploring it here with Dr. Karl.
God, Kate, you asked one question and now we've ended up with 5 more.
Excellent. Thank you so much, though.
Thank you. We've got Dimitar from Meanjin, Brisbane. What's your question?
Hi, I just wanted to know what determines the colour in metals and especially alloys. As the alloys are mixed together, it doesn't seem to be always the quantity of the metal that determines the colour. So I always thought that puzzling.
Are we talking about like alloy wheels here? Is that an example?
And alloys like brass and bronze, which I always had difficulty in remembering until I remembered it was opposite day. So you start off with copper, and if you add something with Z, like zinc, you don't end up with bronze, which has Z, you have brass. And then if you add something like tin, which has got S, you know, tin, the formula for tin is SN, then you call it bronze. So, okay. Overall, it's not the density, it's the surface composition that makes a difference, and occasionally relativistic effects. So if you look at gold and you think, why is it yellow? It turns out that some of the electrons in the inner shells are actually travelling at very close to the speed of light, and this does weird stuff. Overwhelmingly, it's the surface. So in the case of stainless steel is iron plus 18% chrome. The chrome forms a rust which is not permeable and doesn't flake off. Ordinary rust, FeO, iron oxide, water can go through it, air can go through it, and it flakes off, and you leave something out in the open, and eventually it rusts to nothing. But with stainless steel, you get chromium dioxide, which is a shiny rust, and if you go into the physics and the electrons, it is shiny, and then you get the stuff doesn't go through it, air, and neither does water vapor. You look at the different alloys, then you go into a whole different bunch of things, but it's all to do with the surface electron activity. I guess that would be the way to explain it, giving you the colour, not the density of the materials.
Okay.
Sorry.
Yeah.
It's kind of complex. And it's like if you ask an optical physicist, hey, why is glass transparent? They stand back and bring out the cross they keep for such occasions, say, stand back, you hellspawn, you know not what you ask.
Does that help, Dimitar?
A little bit.
Yes. I thought it would be the surface, but when you seem to cut it through, it seems to go right through.
But then you're creating a new surface. And if you're really good, you can get a sharp knife and get some aluminium and cut it with a sharp knife and look very carefully at the groove. And for a hundredth of a second, you can just see it be shiny and then it goes dull as it reacts with the oxygen to make aluminium oxide.
Excellent. Thank you very much.
We got Jazz in Eora, Sydney here. Now, Jazz, you won tickets for our live show on Monday. How did you enjoy the show?
It was one of the best nights.
Yay!
And I brought
The
my
check is
little
in the mail.
sister. The first Dr. Karl experience, and she absolutely loved it.
So good. Okay, so we've got a new fan in Jazz's sister, and you were seated next to someone, Jazz, who kept yelling out "Daddy," right?
Oh, is that the person?
Yeah. If you want to know why they were yelling out "Daddy," you're going to have to wait for the YouTube edit of the show, which is going to be up very soon on Triple J's YouTube channel. But Jazz, you still have more questions. What do you want to know today?
I have so many, but we're going to stick with one because we've got Dr. Krystal here, which is amazing. So I know this isn't a very accurate source of information. I was scrolling TikTok and there was this person talking about the ThreeI Atlas and how it comes from outside of the solar system. In the past, there was one that came through, and because of the shape, people thought it was a spaceship, an extraterrestrial. It turned out it wasn't, which is great. But my question is, what is the ThreeI Atlas object? What do we know about it? And if you're able to elaborate, what do the three of you personally think, what implications that may have on extraterrestrial life?
I love this question, Dr. Jazz. Thank you so much for calling in. ThreeI Atlas has captured definitely the attentions of a lot of us as it's passing through. It's not common that we have an interstellar visitor. Our solar system, for those who may be otherwise unaware, is humongous. It is so much larger than you can even fathom. The distance from, the sun to the Earth is, we call it an astronomical unit, 1 AU. Our actual solar system is like 10,000 plus AU. It is something insane. And so all the comets that we tend to have visit us all come from our own solar system, whether they come from the Oort cloud, which is a theoretical sphere of, rocky objects like comets essentially around us. So this one is a shock, because to have an interstellar visitor coming from who knows where, a very long path, is absolutely, it's super rare, super exciting, but also a little bit terrifying, I'm going to be honest. The reason we can tell it's likely an interstellar visitor is because of the speeds at which it's traveling. So it is traveling tremendously fast, and objects like comets definitely pick up speed the longer that they spend out in space. They can experience slingshot effects by other objects that they pass by. So we know that this one hasn't originated from our own solar system. Whether it's aliens, I mean, I'm not convinced. I know we do have some, well-known names in astronomy who do like to jump to that when it's a possibility. And I do think the question of how have we not discovered life beyond any other surface other than Earth is one of the biggest mysteries for all of humanity, let alone just astrophysics. So I don't think this is probably aliens. I do think it is just a pretty rare and pretty extraordinary interstellar visitor in the form of a comet. It's nice that its trajectory means it's not going to come into any sort of clashes with us, but I do think this is a nice sort of wake-up call about the potential severity of such fast visiting neighbours who travel so quickly that we can hardly see them. Because, for example, I do know that Atlas is about to disappear for a while too. So I think in around September it gets too close to the sun, and we're not going to see it again until December. So they can be tricky to spot, and very quickly passing. So I don't think it's aliens. I do think it's something to be aware of, though. Dr. Karl?
I read the paper by the guy who reckons it is aliens, and this is a person at what's consistently regarded as the best university on Earth, at Harvard, and he's a genuine physicist, Avi, or Abraham Loeb, Loeb, and I read his paper called Comment on Discovery and Preliminary Characterization of a Third Interstellar Object. So that's what the 3I means. And based on a sample size of 2 beforehand, and this one, he goes on to say that this is definitely an interstellar object which is made by aliens because, firstly, it's really big, based on a sample size of 2 beforehand. That's not a very big sample size. It's not that big. It's about 10 kilometres across. Secondly, and he goes on about this, we haven't categorised all the chemicals in it. It's like saying there's an object way on the horizon. I can't see it with my binoculars, so I have to get closer to it. And therefore, because I don't know everything about it, it is an alien, right? That's the second thing. And so that's really weak evidence. And the third thing is it's coming in close to the plane of the planet. So imagine you've got the sun rotating and it's got an equator. And then the planets are sort of all lined up roughly aligned with the equator of the sun, and it's coming in fairly close. Therefore, it's an alien artifact. Not very strong evidence.
I don't know. I'm convinced. I think that was massive. Sample size of 2.
And you said 3, Jazz. My opinion, well, I don't know if I have one.
Usually third time's the charm. So
I'm
who
going to
knows?
say maybe it is aliens.
Ah.
That'll be me.
But it has been claimed that it's going to hit the Earth. The closest it'll get to the Earth is 250 million kilometres.
Okay.
And there's already claims that it's going to hit the Earth. On the other hand, on Tuesday night, I had a dream about it, and it said that it was coming in my dream, it was coming in with a whole lot of other stuff dragging along with it, and some of them may or may not have come close to the Earth and wiped out civilization, and then there were giant flying dinosaurs with wings, and then I discovered gold somehow. It was a weird dream. I don't think it's real.
I think that's off the back of Science with Dr. Karl Live. I think you were just swimming with all these different topics. Jazz, well, jury's out, but we'll have to keep our eyes on this one, okay?
Thank you.
Thanks for your question. Oscar is it Portarlington?
Yeah, it's Port Arlington.
Yeah, nice. What's your question?
Hello, Dr. Krystal and Dr. Karl. My question is, what came first, the chicken or the egg?
Ooh, Oscar.
Ah, okay, so birds are actually dinosaurs, and somehow they survived the big wipeout with the big rock 66 million years ago, and you're saying, well, surely it was because they could fly and go to somewhere where it was better. Yeah, but then all the legged dinosaurs, the land ones, died out, but not the legged reptiles. How come the reptiles survive? That's one of the big mysteries. So you got the birds, and then Australia, they converged in Australia, and then they recolonised the world about 30 million years ago. And then about 10,000 years ago in Asia, almost certainly tied to the fact we started growing rice, some birds got together, loved each other very much, and then there was a mutation. There were no chickens on Earth, and then suddenly there was a mutation, and the thing that came out of the egg was a chicken. Now, this is where you can tell the difference between which came first, the chicken or the egg. So you got this yellow-white gloopy mix inside this eggshell, and almost magically it turns into a creature with a beak and with fluff and a liver and a kidney and an ovary and claws and all sorts of stuff. I find that absolutely amazing. And then it breaks out. Now, here's a question. Is it a chicken only after it breaks out of the egg? Little diversion. The egg is actually weaker when you break out than when you break in. Evolution is wonderful. So if it's a chicken only after it breaks out of the egg and it stands on its own little feet, then the egg came first and then a little bit later the chicken came. But if 2 seconds before it breaks out, that creature inside, it looks just like the one 2 seconds later on the outside. If you say, mate, that's just a chicken, then the chicken came first and then the egg came later. So it all depends on your definition of when does a chicken become a chicken, in the last stages of growing in the egg or only when it's outside. So you get, yes, the chicken came first, both are true, depending on your definition.
Okay.
Messy.
Hey, we've got Matt. You've got a question about black holes.
Yeah. Hi, doctors. How are we?
Good. Yeah, good. How you doing?
Yeah, good, thanks. I just want to know, how do we or don't we know that black holes aren't an entry to another universe or galaxy?
I mean, it's a pretty massive sort of question. Dr. Karl, do you feel comfortable to...
Yeah, so we started thinking about black holes in the 1800s, and there was a scientist who was also a minister of religion in the United Kingdom who started thinking about things that had virtually, as you say, an infinite mass. In other words, the size of a black hole is zero. Not small, not large, but zero. And inside that zero size, you've got anything between 5 and 50 billion times the mass of the sun. And we hypothesised these for a long time, and only with the discovery by the Hubble Space Telescope, we were able to prove they existed. And we looked at the centre of our galaxy, and there were these stars that were orbiting around something. We looked at them over about a 15-year period, and they were orbiting around something that was further away than Pluto. To the sun. So if you think about the sun and Pluto takes like 250,000 years to do an orbit. These things were further out, and so you're thinking, they should take 10,000 years to do an orbit, but they were only taking 14 years. And the only thing when you do the mathematics is that it is something weighing 4 million times the mass of the sun, but there was nothing there. Therefore, it was the black hole. There's a lot of other evidence as well. So we have proved that black holes exist, but the other one, going across the wormy holy thing and getting out of them, in 1935, Einstein, who was a brilliant thinker and a good mathematician, but not a brilliant mathematician, he's good but not brilliant, he teamed up with Rosen. And they wrote a paper in 1934-35 called Einstein-Rosen, everybody calls it that. And they talked about these, they didn't call them black holes then, but these objects. And then they said something, and the best translation from the original German is, they are not singular. These objects, these black holes, they're not singular. They're connected to each other by, wait for it, Einstein-Rosen bridges. And they go and do a whole lot of mathematics on that. Are black holes connected to each other via these things that we now call wormholes? We don't know. We've got no proof. But we do know that black holes exist.
Yeah, no, fabulous. Yeah.
Anything on that?
The sci-fi, the warping over the black hole event horizon, that's where you lose my expertise for a moment. So I appreciate you taking up the helm, Dr. Karl.
Matt, does that help?
Oh, yeah, sort of. Doesn't answer exactly if there's life over there, but...
Is there life the only place we've discovered life is on planet Earth, and every year the astrobiologists have a conference. At the end of the conference, they raise your hands if you reckon there's life elsewhere in the solar system, and everybody puts their hand up, and then raise your hands if you reckon there's intelligent life anywhere in the universe, and half put their hands up. Right now, the situation is we don't know either way.
You are listening to Science with Dr. Karl. We've got Krystal de Napoli with us for National Science Week. If you've got a question, 0439 757 555, get it in. Now, on Monday, we kicked off this week with our live show at the Enmore Theatre, and we had some special guests beaming into the show to ask their questions. In fact, we had someone From the Sydney Swans.
Am I allowed to say Sydney Swans?
Yeah,
Okay,
you're
the Sydney Swans.
Yeah.
I have no choice as a loving father but to have them as my favourite team.
We've got one of them to ask you a question.
Oh, my God, yes.
Hey, Dr. Karl, it's Errol Goulden here from the Sydney Swans. We think that the universe is constantly expanding. I want to know, where is the universe expanding to? And also, what do we think is beyond what we can currently observe in the universe? Thank you.
Oh, my God. The overall answer is it's expanding into the future. We don't know. Why don't you look over there at that monkey and walk in the other direction? This is where the theoreticians start writing things down, and we don't know what it's expanding into. Actually, at one stage, I had Kip Thorne, who won a Nobel Prize for black holes, and we had Roger Penrose, who won a Nobel Prize in physics also. And then somebody came in with a question that was really deep, and it was all coherent. And they looked at each other and they said, "Are you trying to get us to do your PhD for you?" And he replied, "No, mate, I'm just a forky."
He's just a forky, but he's got the deep questions. Now, Dr. Karl, you kind of answered that one on the night, but Krystal, do you have anything to add to Errol's question? You know, what is the universe expanding into?
I know, this is one of those, I feel like some of the most interesting questions in astronomy often end with the we don't know, which I know is super unpopular, but universal expansion, if you want to think about it, it's like, I like the analogy of like raisin bread. Right? So we have like a beautiful amount of dough with lovely raisins all through it. And as you bake this bread, it can start to rise. And yes, the raisins and all that thing will stay the same size, but the area between them expands. And so the universe is certainly expanding. We can see it through a different number of ways. One of the most common is this idea of redshift. And so essentially we have a lot of stars in the universe. We know their properties super, super well. And we can see that what's happening to their light is that it is getting stretched sort of away from us. And we have an equivalent experience like this on Earth in the form of sound. So we get the Doppler effect through sound. It's that similar sort of like, zoom, you know, zoom of a car, or like the wee sounds of sound waves either getting further away from us as they're getting emitted or coming closer. It essentially makes the perception of it to us seem as though, you know, these sound waves or these light waves are getting lengthened. And so that means either the sound becomes deeper, or when we see the light, it means that the light actually becomes redder in colour. It shifts along the electromagnetic spectrum. And so when we look at all these beautiful stars and galaxies, we can note that when it comes to a lot of these galaxies, especially the further away from us they are, that they are certainly expanding. They're moving away even faster. So the universe is expanding. All the space in between a lot of these galactic objects are expanding, but we don't know what we're expanding into and whether we're expanding into anything necessarily. Like perhaps there is nothing, and that's something we're trying to apply because we're used to it in our experience on Earth, but we are just the bubble that is expanding. Everything that is contained within.
I really like that raisin bread, raisin toast theory though. That is good. I'm imagining it in my head now. Hey, you mentioned sound. We've got Laura from Penrith here. What's your question?
Hi guys, I had a question about sound waves and how they move through particles. So my understanding is that when you make a sound, the reason it's more difficult to hear further away, or that sound doesn't keep going, is because the energy dissipates into the air particles. So I was wondering if it is possible, or if it might ever be possible, to invent or create a container made of a material that wouldn't allow that sound to dissipate or be absorbed into the material of the box. So essentially, you know, is there a possibility that in the future we could say something into a box and then in 2 years' time someone could open that box and hear what we said?
Wow. Okay, one solution obviously comes from Einstein. So you speak into the air and then you magically create a box that captures, say, 1 cubic metre, and then instantly you move that box at 99.99999% of the speed of light, and then time slows down inside that box, so that 1 second inside that box is like a million years for us. And so when you open it up in a couple of years, there hasn't been enough time in that box for the sound waves to dissipate into the body of the material of which the box is made and turn into heat. That's one way. The other way would be to have a perfect sound reflector, but then I'm kind of thinking you'd run into all sorts of resonances and you would interfere and you'd get a sort of a boxy room echoey effect. So I'm sticking with Einstein's the cure for this one.
All right, we have to go to speed of light, seems like.
Yeah.
Afraid so, yeah.
Also, Laura, I think you've come up with a great concept for a movie as well.
Oh my God.
You know, people trapping secret messages in boxes and then they can only open them later on. Copyright it, Laura.
I will. The solution is time travel.
We should pitch it to the big boys.
100%. Hey, we can do that now. We've done a live show. Laura, thank you so much for your question. We got Matt from the entrance. Matt, what do you want to know?
G'day, guys. How are you?
Peachy keen, Dr. Matt.
Hey, thank you. My question is about temperature. So I know that there's an absolute zero where atoms stop moving, but is there a maximum temperature? So is there a ceiling for how hot things can get, or is it just the sky's the limit? Can you keep going? Is it so? You know, is it 1,000,000 degrees, 1,000,000,000 degrees, or can we just keep going?
Funny you should ask, but I actually have an answer that I prepared earlier.
Really?
I was worrying about this myself, and luckily we have morning tea in the physics department every week, and so I asked the clever people in physics, and luckily I had 3 different people. And there is a maximum temperature. It's 1 followed by a whole bunch of zeros, and the exact number of zeros depend on whether you're talking thermodynamics, relativity, or quantum. And in each case, they went on for about 10 minutes about how it was this number or that number. And then the other one would cut in and say, yeah, but that's from a quantum point of view. From a thermodynamics point of view, blah, 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 10 minutes, undecipherable English, and this is the number. And then, but that's from a quantum point of view. So the answer is, yes, there is a maximum temperature depending on which way you're going. But is that the case in reality? We don't know, because we still don't fully understand quantum mechanics, and it still doesn't make sense to me. Sorry.
Okay.
Sorry, Dr. Matt.
No, that's fine. No problem. No, appreciate your time. Thank you so much.
Thanks, Matt. We've got Louis in Coffs Harbour. Dr. Louis, what do you want to know?
G'day. I might need to update my address. I'm not in Coffs anymore. I do have another question about something we know very little about. I've been watching heaps of videos about a whole bunch of scary space facts. One really stuck out to me. This guy talks about a massive region of space, unbelievable mass outside the Virgo supercluster. It's estimated to be about 1,000 trillion times the mass of our sun, pulling all galaxies around towards it. And I was just wondering if you guys had any thoughts or speculations on what this quote-unquote Great Attractor could possibly be.
Excellent. Thank you, Dr. Louis. I love this question. For those though at home who perhaps, haven't been down the similar YouTube rabbit hole and don't know these words or this idea, I think it's really cool to actually start visualizing our universe on those larger scales. Because from our perspective, we are orbiting around our sun. We have a nice little solar system. We have a lot of planets for any other solar system. And we have life. How beautiful. And so we know we sit in our galaxy. Our galaxy is a spiral galaxy. We're out in the outer suburbs about 2/3 of the way out. And I sort of feel like at that point, I'm like, cool, the universe is then filled with hundreds of billions, if not trillions of galaxies. And I imagined that this was sort of like a random order, almost like we're all little boats sitting on the waves of the ocean. That is the universe. But the crazy, crazy thing is, so our galaxy holds hundreds of billions of stars. Yet when we start to zoom out of the universe and start looking at it as though, reducing to the scale where even our Milky Way galaxy becomes a little pixel, although it is just a star in the night side, what we see is that our galaxies do tend to have, well, at least our universe tends to have this overall large structure. You could think of it as though it's like a bit of like a sponge or Swiss cheese, but what we're finding is essentially galaxies and a lot of large objects tend to move along and to actually stick to parts of space rather specifically. So we have like big sort of areas of a whole lot of nothing. So we have a lot of voids. And then we have these chains and links of galaxies that are, living in the same sort of neighborhoods or otherwise gravitationally connected. And so when we zoom out of even that, we see our galaxy neighborhoods that we love to chill in clusters and superclusters of just all these other hundreds of thousands, if not more galaxies coming together in the universe. And as you're referring to, once we keep zooming out, we are noticing that all of these galaxies, especially the ones related to the Virgo supercluster, which is the one that the Milky Way galaxy, our galaxy, is a part of, we're noticing that they all seem to be moving quite fast towards this great attractor. So the Great Attractor could be a lot of things. It could just be simply the fact that we do have all of these, this gravitational incentive of a way of all these galaxies coming together, flowing into this part of the universe. And what we're actually acknowledging is just the presence of all of those galaxies there together. So the Great Attractor being that density of them all. There is also thought, though, to be other large gravitational structures beyond the Great Attractor. So I know some of the fear might be coming from this idea that we're heading towards this like dead end where we're all going to get sort of, densely trapped in. But the reality is, I think it seems more so that this is a natural flow to the universe and that this is us sort of traveling down a certain stream that a lot of other galaxies are. So the Great Attractor, it is a little bit of a mystery. It could be a density of the galaxies coming together. It could be a density of dark matter that's attracting the galaxies to that particular part. But evidence does also point towards there being a place beyond it. So I don't think we're heading to anything too scary. I think it just shows that we're part of a much larger system. And it really blows my mind when we start thinking about the universe on those very large scales and realising it has structure, it has patterns, and it has rule. Hopefully that helps.
Yeah, that's way better than any answer I've ever gotten on YouTube. So
Good. Thanks, Dr. Louis.
Exactly. If you've ever not found an answer via YouTube, this is the place to be. Science with Dr. Karl. We did our live show on Monday and we had some special guests who beamed into the show. One of them was a friend of the show, Dave from Glass Animals. Next question is an artist who actually joined us on the show last year. He had a stack of questions for you.
Yep. Come on, Dr. Dave.
Karl, what's up? It's me, your biggest fan, Dave from Glass Animals. And is teleportation ever going to be possible? And if not, what will be the fastest way that we could ever, as humans, get around the globe?
Teleportation means reading every single atom in a human body, and there's 60% are oxygen atoms, but there's maybe 30 or 40 different types of atoms, and then putting them together in exactly the right order in the right places to make collections of atoms that we call molecules, and then incorporating them into cells and being able to do all of that absolutely perfectly, but we don't know the answer. So I'm thinking a better way of getting from London to here is the missing 8 dimensions. So the normal dimensions we know are backwards, forwards, and then left, right, and up, down. So imagine the world is flat and there's a spot on that cupboard over there and a spot over there. And if you want to go from there to there, you have to walkie all the way. Mm-hmm. But we, living in 3 dimensions, using the higher dimensions, can come along, pick up that carpet and kiss that corner to that corner. And that's one of the possible things that we might be able to do in 20 or 50 years or 100 years or 1,000 years, use the higher dimensions to travel from here to there without crossing the distance in between.
Teleportation. Krystal, anything to add to that one? Or
well, teleportation, I mean, I love the idea and the concept. I do love the connection with high dimensions. I think it's marvellous. For those who might struggle to visualise that high dimensions, that 4th dimension beyond our 3D reality, sometimes it can be easier to visualise what the 2nd dimension looks like from our perspective as a 3D object. For example, if we had a 2D being living stuck on a little page, if we draw a little box around them, from their perspective, they can't see beyond the boxes and they're trapped into their little world. Whereas for us, I mean, we're looking from the tippy top and I can reach my hand down and theoretically grab into this little box from the top that they don't even know exists and remove them without any harm, without them realising. No. So from their perspective, they would imagine rips in the paper, rips in their theoretical walls. From us, though, we can quite literally lift our hand in very calmly and take them out. And so you can bring that up to the 3D and the 4D. So I just like that little notion because it's similar to like a 4-dimensional surgeon on a 3D body. I mean, we could take our heart out, get it checked and nice, put it back in, no stitches. So I do like linking this to teleportation. I think that's an answer.
Yeah, I'm loving these visuals that you're coming up with as well. We've got the little character in a box on paper. We've got the raisin toast. Joe in Ngunnawal country, what's your question?
Oh, hi. Thank you so much for taking my call. We're huge fans. I'd like to give a quick shout out to my husband, if that's okay. We listen to your podcast every time we do a road trip, Dr. Karl.
Aww.
I have a question actually that's inspired by my son. He's also really into science at the moment. We've been listening to a few science cards. One of them was about out of space, and it was talking about the gas giants and how they're mostly made up of hydrogen and helium. And on the other hand, him being a 4-year-old son, he's also very into fire and explosions. And so naturally,
he's a guy, we get it.
the two elements have combined, and I feel a little bit like Darth Vader asking this, but I was just wondering if say we had a rocket or some kind of a spacecraft that used a combustion engine or any kind of flame, would it be possible for us to accidentally blow up one of our gas giant planets?
Joe, you're a monster. Krystal, what do you reckon?
Yeah, so Dr. Joe and Dr. Little Joe, thank you so much for bringing this question to us. So when we have combustion type reactions, we do need certain components. One of those is an oxidizer. So oxygen, on Earth, we know that flames can't survive without the presence of oxygen. In space, it is famously a vacuum. And so we actually have to, when we launch rockets, bring our own oxidizer to the party. So that is how we're able to sustain, for example, rocket travel and burning through rockets. So when it comes to our beautiful gas giants, they are full of gas. Helium isn't going to burn, it's inert. It's a beautiful one like that. Hydrogen, though, it would like the chance. But the thing is, there isn't a presence of a strong enough oxidizer there to ignite a whole planet. And also, even if we started a little bit of an ignition, it would likely dissipate pretty quickly because it just doesn't have enough to propel it.
But theoretically, if we had a gas giant made entirely of oxygen and we brought them together and then went like the match, it could theoretically happen if we had oxygen and hydrogen together, perhaps.
Yes. Chuck some oxygen at Jupiter and I think we can make it work.
Yeah, all we need to do is get something 10 times the size of Earth, full of oxygen, and bring it over. That's
Easy
all.
as. All right,
Yeah,
we'll work on it,
engineering.
Dr. Joe, and we'll be back in touch.
Thank you.
And Joe, for now, you just need to work on your evil Darth Vader voice and then we can make it happen. Thanks, Joe.
Will do. Thanks.
Hey, Krystal, thank you so much for joining us for National Science Week. If people want to hear more about your research, you've mentioned some things that you've already started working on. Where can we go? What should we search? Where do we look?
Oh, yes, I've made it harder to find me nowadays, but I am trying out on Instagram. So if you look up Krystal de Napoli, my name's a bit of a challenge, but
Is that with a C or a K,
So
Krystal?
it's with a K, so Krystal, and de Napoli, like the sauce, DE Napoli. I try and share science content, and I'm looking forward to creating some more in future. So catch me there, or you can catch me in the classroom at Monash University. I teach Sci 2030, which is the Indigenous Science course there, which is marvellous.
Hell yeah. Thank you so much for hanging out with us. We really appreciate it. Happy National Science Week.
Thanks, Dr. Lucy.
And Dr. Karl. We'll do this again next week.
Peachy keen.
And that's it. Thanks so much for listening to this week's episode of Science with Dr. Karl. A happy National Science Week to you. Krystal de Napoli, thank you so much for joining us as well. You can check out her Instagram like she mentioned. We'll have a link for you in the show notes. A huge thank you again if you came along to Science with Dr. Karl live. And we've got plenty more from the show to drop into your feed over the coming weeks. So make sure you subscribed, liked, whatever you got to do. This episode was produced by Josh Brennan. I'm Lucy Smith. We'll catch you next week. Bye.
Dave Marchese here from the Triple J Hack team. Hey, if you love Dr. Karl's podcast like I do, you might enjoy the Hack podcast as well. Each day we bring you the news that matters to you, from the latest science on climate change to what's happening in politics and news around the world. The Hack podcast. It's your daily fix of the news you need to know. Get it wherever you're listening now.